Hello everyone, and welcome to the lesson on area under curves by integration and trapezoidal rule. So let's jump straight to the question and see how we're supposed to solve it. So in the figure below, the shaded region is bounded between the line y is equals to 15x and y is equals to 3x squared. So there is the diagram, you can see it. So there's a shaded region. So part A of the question, determine the coordinates of P. Then part B of the question, by integration, determine the area of the shaded region. And then have a third question there. Estimate the area of the shaded region using the trapezoidal rule with 5 strips. So those are the questions. So there are 3 questions. So let's jump to the first one. We start with the first one, then we proceed. So determining the coordinates of point P, that is the point of intersection of those two curves. So in order to determine the point of intersection, that is the coordinates of the point of intersection of the two curves, y is equals to 15x and the other one y is equals to 3x squared, we shall take that 15x and 3x squared and equate them. They are both functions of y. So 3x squared is equals to 15x. You can do the vice versa. 15x is equals to 3x squared as well. That is what will give the point of intersection of the two curves. Now, to solve this, we want to find the x coordinate. So 3x squared negative 15x is equals to 0. So we solve this equation, we shall get two values of x. So 3x is common, x minus 5. X minus 5 is equals to 0. And this will give 3x is equals to 0. And if this is the case, x is equals to 0. That is the first value of x. And then the second value of x is negative. This x minus 5 is equals to 0. So x will be 5. So we're going to ignore x is equals to 0 since when looking at the curve, now that point of intersection cannot have the x coordinate as 0, so we take 5. So that at that point of intersection, the value of x or the x coordinate will be 5. So it will run from 0 to 5. So therefore we have x is equals to 5. So therefore the point of intersection, that is a P, is given by 5. So we need to get the corresponding y value at that point. And to do that, we can use either of the two equations. We can use y is equals to 3x squared or y is equals to 15x. Any of them will give the correct answer. So let me use 15x. So substitute x is 5. So y is equals to 15 times 5. And this will give the corresponding value of y as 75. Therefore, the point of intersection, the coordinate will be given by 575. And that is how you're supposed to get that. By integration, determine the area of the shaded region. By use of integration method, find the area of the shaded region. So to get the area, shaded area, we shall integrate the curve that is above, that is y is equals to 15x, and then that will give the area under that curve. Then we subtract the area under the curve that is below. When we subtract that, it will give us the area of the shaded region. So the shaded area is given by the integration of and that is from 0 to 5, because we have obtained the value of x is 5. So 0 to 5, that equation, that is a function of the curve that is above, that is 15x. That will give the area in that curve. Then we subtract from x is equals to 0, we integrate the other curve. So when you get that, that will definitely give the area of the shaded region. Now let us integrate these 15x. It will give 15x divided by 2 plus a constant c, and then the limit is from 0 to 5. Remember, we got the x interval, the point of intersection, that is from 0 to 5. Then the other part, when you integrate, you get x cubed plus a constant c. Again, we still getting the area between 0 and 5. Between 0 and 5. So having done that, We can now substitute 5, that is 5 squared divided by 2. We shall not consider that constant, since when you work it out, that constant will definitely get subtracted and give 0. So we subtract 15 over 2, then we substitute 5 and 0. Then for the other one, x cubed, we substitute 5 and 0, we subtract 0. We have ignored c since it will definitely subtract and give 0. So when you work out these using the calculator, these will give 100, I think is something to do with 15, 187.5. That is minus, this one will be 5 cubed, which is 125. This gives 62 square units. 62 square units. So that is the shaded area using the integration method, and that integration method gives the exact area under the curve. That is very important to note, that by use of integration method, that gives the exact area. Now let's get the estimation of the area using the trapezoidal rule with 5 strips. So the same, you're going to do the same. We shall get the area under the curve y is equals to 15x. That will give a whole area below that curve. Then we subtract the area under the other curve. That will give us the area of the shaded region using the trapezoidal rule. The first thing we need to do is to get the height, but let me write this. The shaded area is very important to note this. That will be the area under the curve y is equals to 15x, which is very important to note this. Subtract the area and the curve y is equals to, this is 3x squared. So that will give the shaded area. So area, therefore the area under the curve y is equals to 15x. We start with that. That is what you're going to begin with. So we start by getting the interval that you're going to use. Remember, we're using 5 strips. So to get the height, since we are getting the area between 0 and 5, 5 minus 0 divided by 5, that will give the width. That's the interval of 1. So 1, the interval of the height, that will be 1. So after getting that, the next thing we can do is to construct a table of values. Now using that interval between 0, remember we got the point of intersection, those curves, they're intersecting at x is equals to 5. That is why we are taking the limit from 0 to 5. So let's construct this table. All right, there is a table. This is x and y. 0, 1, 2. The height is 1, 3, up to 5. And then using that function y is equals to 15x to fill this table. So substitute the value of x with the x values there to get y. These I'll do it very fast. This will be 0. This will be 15, and you do this will be 30, and this will be 45. Then the other one gives 60, and then 75. So that is the table. When you definitely give the values, it's good to give these y1, y2 to give the height, so that you can substitute in the formula. Y1, y2, y3, y4. This is y5 is okay. So now the trapezoidal rule is given by half height, the first plus the last, then plus twice the sum of the remaining, that is y2 plus y3 plus y4 plus y5. That is the trapezoidal rule. That is why I've used the y1 up to y6. So substituting those values, In the equation, half times height is 1. Height is 1. Then we have the first, which is 0, the last, which is 75, then plus twice the sum of the other values in the middle. So you have 15 plus 30 plus 45 all the way to, this is what, 60. So very fast, using the calculator, we have a half, then this will give what? This will give 75 plus twice all the other values will give 300. When we work it out, this gives half plus 75 plus this 25 plus the height will give 187.5 square units. So that is what you get. That is the area and the curve on the top. The curve on the top. Now let's get the area under the curve that is below, and then you subtract to get the shaded area. So area under the other curve that is below, that is 3y is equals to 3x squared. And this of course the height will remain the same because using the 5 strips we have a height of 1. The limit is from 0 to 5, is the same. So let me create the table of values again for this curve very fast. Okay, it is okay. Now we have these let me draw this one very fast, and we have so x and y, then 0 1 2 3 4 all the way to 5, and then we fill the table using that function, that is y is equals to 3x squared. That is what you're going to use to fill the table. So very fast, this will give 0. The first one will be 0. Then we have 3 1, this is 12, this is the other one is 27, this one is 45, and the other one is 75. Now y1 y2 the height, y3 all the way to y6. The trapezoidal rule states half height, then you have the first plus the last, then plus twice the sum of the remaining values, there's the ordinates, the sum of the middle all the way to y2 all the way to y5. Substituting those values of y and h, we get, so half height is 1, and then we have y1, this is 0 plus 75, then plus twice the sum of the middle terms, that will be 3 plus 12 plus 27 plus 45. Yes, that is the end, I think. Then you close the bracket. Working out these, we get a half multiply by, give a half plus this times 75 be 75, then plus twice the sum of these will be 180. When you add that, that is what you get. And then working these using the calculator, this is what you get. So this gives 3 plus 12 plus 27 to give 127.5 square units. 127.5 square units. That is the area under the second curve. Now we can now proceed. Having the two areas, we have got that, the area below and then the area on the top of the other curve, 187.5. Looking at the, we are getting the shaded area by subtracting the two areas. So the shaded area therefore will be the area under the curve the top, which is 182.5. Then subtract the second area we've obtained, 127.5. Then this will give us 60 square units. 60 square units is the area of the curve, and that is simply how we're supposed to get the area under the curve by use of the integration method and the trapezoidal rule.